Thank you, sir. We'll go ahead and do properties of logarithms. All right, the first page, we're going to talk about properties of logarithms. This is on the ACT. If you plan to take it, you will see this somewhere, logarithms on the ACT. Are any of y'all going to be taking it? Good. All right, so this will be there. The first thing you talk about with the ACT and the logarithms, they'll probably have a question on there dealing with one of these three properties. The first property that they have is going to be log. Well, my pen's not writing. Give it just a minute. Of m times n. That's going to be equal to log m plus log n. In other words, you can expand this right here. You can expand that to be an addition problem. And then you can take this addition problem and you can condense it to be a multiplication. So this goes both directions. So looking at the quotient property, you have log m over n. That's going to be the same thing as log m minus log n. Did y'all do this last year? Oh, okay. Do what?
We probably missed it because of COVID.
And then the power property. You're going to have log m raised to the nth power. So what you're going to do with that nth power, you're going to move it down to the front. It's going to be n times log m. Now, something important for you to remember, this n cannot be multiplied to that m. Those two things are separate. This is one whole quantity. So don't ever try to multiply that n to that m. That's not going to work. So be careful with that. All right, so there's some properties we need to keep in mind. And if it's all multiplication, then what property, product, quotient, or power property, which one of those am I going to have to use? The product, isn't it? So we've got three different properties that we talk about. The first one is our product property. And we're going to take and look at positive numbers m, n, and b, where b doesn't equal 1. And p, any real numbers, the following properties apply. So what you're going to do is take some logarithm log base b. And if we have m times n, if you're multiplying within that logarithm, that argument there is multiplying, you're going to expand this by addition. Log base b of m plus log base b of n. And this goes both directions. So if you had something that was expanded and you needed to condense it, and that expanded was with addition, then you can condense it with multiplication. So the quotient property, a quotient, keep in mind that means division. So if I have log base b of m over n, then that's going to be log base b of m minus, so this one would expand using subtraction, log base b of n. And again, if you had something that was expanded with subtraction, you can condense it with division. And keep in mind that the positive part was your numerator, the negative part was your denominator. So do keep that in mind. And then you have your power property. So if we had log base b of m raised to the nth power, what you're going to do with that is move that exponent n down to the front, and it's going to be n times the logarithm value of log base b of m. Now that's not saying you can multiply n and m. Don't do that. What you have here is a part where you can multiply this whole value here. You've got to take this whole value into consideration. Find that value, then multiply it to n. But you can't multiply n and m, so don't make that mistake. That's a common mistake that always happens. All right, we're going to use these. We're going to use those, and we're going to expand these problems here. So notice that we have all multiplication here. So, okay, so if we expand with the product, what sign are we going to use? Are we going to multiply, add, or subtract? Add. So this is going to turn into log 8 plus log x plus log y to the 4th. Now we're not finished because we've got this exponent here. Okay, so what property would you think we're going to use with that exponent there? Yeah, that 4 is going to move down to the front here and become multiplication. So our final answer is going to be log 8 plus log x plus 4 times log y. There's your final answer. Okay, so in part B, when we have any kind of radicals, then we change those radicals to exponents. That's how you deal with those. So what exponent means the same thing as square root? Y'all remember?
It'd be like negative.
It's not going to be a negative. It is a fraction though.
Oh.
1/2. There you go. So whenever we're doing this, we're going to change that right there and say it's really to the 1/2 power is what we'll do. Now if it was cube root, it would be to the 1/3, and if it's 4th root, 1/4, and so forth. All right, so here we've got a fraction, so we'll separate this using subtraction, okay? So we're going to have natural log of x squared plus 5 to the 1/2 minus natural log of x. And then what else do we need to do?
You gotta get rid of the 1/2 power.
Got to move that 1/2 down. So that's going to be 1/2 natural log x squared plus 5 minus natural log x. All right, questions about it? So again, if you're multiplying, you separate all that with addition. If you're dividing or you have a fraction, then those separate to subtraction. All right? Now let's go the other way. And we're going to do some expanding and condensing here. So using this, on our first one, we've got log 8xy to the fourth. That is all put together with multiplication. So that is going to be our product property. And notice how we expand that product property. We expand it with addition, don't we? So we're just going to break all this apart with addition. So we're going to say log 8 plus log x plus log y to the fourth. And then we have one last thing. We can't have this 4 up here. That's not completely simplified. This is going to be our power property. We're going to have to move that 4 down here to the front. So our final answer is going to be log 8 plus log x plus 4 log y. Okay, moving on to part B. Same idea again, except for here we're got our division, so that does mean subtraction. And then we're going to change this square root. We're going to rewrite that. So we're going to have natural log, and we need to think of some exponent that means the same thing as square root. It's some fractional exponent, and that exponent is going to be 1/2. So if you've got some kind of radical, then you're going to rewrite that using some kind of fractional exponent. Now we're ready to do some expanding. So here we're going to have natural log of x squared plus 5 to the 1/2 minus x, natural log x. And then we've got to move this exponent down to the front. That's got to move down. And so we have 1/2 natural log x squared plus 5. And then minus natural log of x. Right? Now let's condense this. We're going to condense it. So in part A, example 2, part A, I would move that 2 up to the front first. So we've got natural log x to the 5th minus natural log xy raised to the 2nd. Okay, and the way I think about this is we know it's going to be a fraction because you're subtracting. So I do natural log, and I just go ahead and I draw a fraction. If it's positive, then you put it on top, and if it's negative, you put it on bottom. So natural log x to the 5th, that's positive, isn't it? So x to the 5th goes on top. But minus natural log xy all squared, that's a negative term, isn't it? So that goes to the bottom. So you're going to put xy squared in the bottom. Now, right here, though, we can simplify this because I've got an x squared and a y squared really sitting down there. So we have natural log of x to the 5th. We'll have a lot of algebra coming back here. x squared, y squared. Now, what can we simplify there? There you go. So, what's going to be left? X to the third over y to the second. That whole thing is your answer. Is that okay? Right? What would B look like? Log.
The 5 doesn't really mean anything, does it? In this case.
It will be used.
But it won't be moved, is what I'm saying.
No, it's a positive.
Yeah.
You're subtracting, so you know if there's a subtraction, you know it's a fraction.
It's log
5 over what? Yeah. Because log 5's a positive term, isn't it? So it goes on top. And log x is a negative term, so it goes on bottom. Groovy? Alrighty, let's try the last one. So I would move up that 3, and I'd move up that 2. And if you can go ahead and distribute through, go ahead. I think a lot of people forget, though, what to do with your exponents. Because you forget whether or not is it to add or to multiply there. That is the question. So if you have an exponent raised to an exponent, do you add them or do you multiply them? No. Exponent.
You're raising one power to another.
Because it's exponent raised to exponent, you multiply those right there. That's a common thing that always gets kids. So right there, it's not like you do it every day, right? You don't go to Walmart and say, hey, give me those 2 exponents right there. I want to multiply them. Not at all. So you're going to get what? X to the 9th. Log y to the second, z to the who? Well, you're adding, so how are you going to shove this crap together? You're going to who? Woo-hoo. X to the 9th, y to the 3rd, times y squared, times z to the 4th. Can you simplify? Something there I'll put together. What about these two? Y cubed and y squared, what will that become?
1 to 2, wind up x to the 9th,
Y to the 5th, z to the 4th. Awesome. All right, so before we go much further, now that we've got those, y'all flip over to your homework page, and y'all go, I think it's 1 through 12. Yes, y'all practice 1 through 12, and then we'll put up the answers. And see how you do with them. Y'all work together if you want to and ask each other questions. Any questions? Mm-hmm.
What's the little 2 at the bottom do?
Which number?
6.
Just carry it through. It's okay. Just keep it with the log.
Blank is that multiplying or?
It's just a base other than 10. It's base 2.
Okay, so I don't have to do anything with it. It's just
No.
gonna keep log. Okay. Gotcha.
let's check our answers. Now, a couple of these, if you have this, then that's perfectly okay. They went ahead and said 16 is really 4 squared and then moved the 2 out front, which is silly. I mean, if they were really gonna do that, it's 2 before, that they're going to simplify it down all the way. Number 2, natural log 3 minus natural log y. Number 3, they threw in some things we talked about in the previous lessons, but let's write ourselves in a little note here, because does anybody remember how they got 3 there? Any clue? Alright, so natural log of e is 1. We had that earlier lesson, but I don't think we remember, so we're going to write it again. And we also have natural log of e to the x is just x. And so when we break this apart, that's the situation we have, is natural log of e to the 3rd. And so natural log of e to anything is just the anything. So natural log of e to the 3rd is just 3. So that's something that's going on there. I would write this in, because that's going to be where you're simplifying that you need. So do write that in. And there's nothing wrong with having natural log of e to the 3rd as a step. That is a correct step. It's just you need one more step to simplify it. And the same is true with 4. How many of you have log 1,000 on your papers? Wonderful, that's correct. But then the next step is simplifying it. Now, what base is understood to be here if it's not written? Do y'all remember?
10.
Base 10. So this is really saying 10 to what power is 1,000? Well, 10 to what power is 1,000? Count your zeros if you're not sure. They never lie to you.
100.
So how many zeros are there? 3, right? So 10 to the 3rd is 1,000, so that's why that 3 is there. Because this whole thing simplifies down to 3. And I would probably write that in because, again, not going to remember. And we're going to stay right here and focus on logs simply because it is on the ACT to make sure y'all understand it. And y'all didn't do any of this last year.
No.
Okay. What about number 5? How did y'all do on 5?
I got that, but instead of, I just distributed the 1/2.
You put it to each one?
Yes, ma'am.
There's nothing wrong with that. That's perfectly okay. And then what about number 6? Now, if I'm ahead of y'all, let me know. Had a couple of cups of coffee and a Dr. Pepper, so I'm fueled up. Ready to go. Good. Number 5. Right here. Are you okay with the 1/2? Do you know where that came from? Alright, anytime you have a radical, you're gonna drop that radical and change it to a 1/2 power. Okay, so that's brought outside. That's where it came from. Okay, have y'all gotten past 6? Alright. Now, on number 7, do you have log base 2 of 16?
Yes.
Okay, so where the heck did the 4 come from? Anybody got a 4 on their paper? Some do, some are like, heck no. This is saying 2 to what power, what exponent gives me 16? So 2 to what power is 16? Well, 2 to the 4th. So simplify all the way down when you can. If you're not sure where the 4 came from, again, over to the side, put your 2, question mark, equals 16. Remind yourself. And this one, number 12 on y'all's paper, second period said there's a square there.
Yes.
Is there a square on y'all's paper? Yeah. Okay, so that's gonna throw this one to be a square right here, isn't it? Yeah, 'cause it's negative, goes on bottom. If you had borrowed one of my calculators and taken it and used it, I need them back for inventory. So if you have one, please bring it back so I can have it to inventory it and then you can borrow it again. But they are getting pretty thin, so leave those back.
We go over number 11.
Sure. Number 11, right here, that 1/3, and notice it's on the outside of this bracket is for all of it. So that means that this is the cube root of everything. Is that okay? And then the 2 goes up to be x plus 1 all squared. And it's a positive term, so it goes on the top. But then your minus x and minus x minus 3, both of those are negative, so they both go in the denominator.
Gotcha.
Don't build a complex fraction there. I know a couple of people did last
That's what I
period.
did.
Did you build a complex? Don't build a complex fraction there. Think positive goes on top, negative goes on bottom. Okay, is there any others? Are there any others? Y'all okay with it? And we'll practice this more tomorrow too, but any others? How much time we got?
7 minutes.
7 whole minutes. Alright, we'll do change of base. Do y'all have a calculator? No, no calculators, use your phone then. Turn it sideways. Alright. We're gonna do change of base. It is not difficult, it's pretty quick. I get my screen back. There we go. Try somewhere we condense. So now we're going to go through and try to put some of this together and do some simplifying as we condense it. So for our first part here, I would go ahead and move that 2 up and distribute it through to our x and y. So you got natural log of x to the 5th minus natural log, and that's going to be x squared y squared. If we move that 2 up to the top and then distribute it, and then we're subtracting, so that tells me that we need our quotient. So that's going to be natural log. This term is positive, so our x to the 5th goes on top. This term is negative, so that tells me that x squared and y squared needs to go to the denominator. And then we can do some simplifying here, because x to the 5th will cancel with x squared, leaving an x cubed on top. So we have natural log of x cubed over y squared. Okay. Moving on to the next one, part B. There's really nothing to move up, no exponents out to the front or anything like that. So this one, just condensing it, you're going to have log. This term is positive, so the 5 goes on top. This term is negative, so the x goes on bottom. So it's log 5 over x. All right, now part C is a little bit tougher. Let's see what we can do with it. We're going to move our 3 up to the top. And so we're going to have natural log. If we move that 3 up to the top and distribute it through to each part, that's going to be x to the 9th, y to the 3rd, and then plus natural log. And then that's going to be y to the 2nd, z to the 4th. And again, that's because I'm moving this exponent up to the top and distributing it through. And remember, if you have an exponent raised to an exponent, you multiply those two. You don't add them, you multiply. Now, you are adding these, so to condense them, you would multiply. So I'm going to multiply all of this gobbledygook together. We got x to the 9th, y to the 3rd, and then y to the 2nd, z to the 4th. So we need to multiply all of that together. So we're going to have natural log of x to the 9th, y to the 5th, and then z to the 4th. Oh heck, I forgot to erase that. All right, change of base. Let's say we've got log base b of x. B log x over log b. That's all you do to change a base. So what that's saying is, and why we need to do that, is because our calculators, even your cell phones, they're all built in base 10. That's our whole number system is base 10. So what we have to do for our calculators to calculate things in other bases is we have to change it to a fraction. And so when we do that, this is what it looks like for us to type it into our calculators. Now we're going to do our change of base formula, and this is an older formula. Some calculators don't need you to do a change of base formula, and some do. So in other words, if we're working in a base other than base 10, then we're going to have to divide this up and say log and make it base 10 of x. over log base 10 of b. And notice how we've taken our x up here and our b value down here. And then you can type it in your calculator and it will do, and find your answer. So, look at part A. We can't type that into our calculators. So what we can do, because it's in base 3. Now what we can do though is change this to say log, well crap, log 13 over, what would be in bottom? Log 3. Now in your, get the answer, there you go. So in your files, you get the calculator and turn it sideways and you should see logarithm there. So you're going to do log 13 and then divided by log 3. You should get 2.335. That's what we got last period. Did y'all get it?
Mine says error, 2.33.
Yep.
You have to type in 13 and hit log 10, then
Yeah.
type in 3 and then.
Oh, I forgot about that. Y'all have to type it in backwards.
3 and then log.
You're going way back with the phone then. That's how we used to have to type it in. I was thinking y'all might have to just do it the other way. Their phones.
Not on the calculator.
No. Oh well. All right, y'all try B and C. So that's going to be log 10 for log 6. I would just do 0.5 instead of a fraction. And we'll stop here. Let's see. Is there any of your homework? All right, on your homework, using a calculator, do 13 through 22. I know it says not to use a calculator, but that's crazy. We live in the technology world. You'll be able to use calculator on the A16.
That's pretty good.
I hope not. I got you really hope not.
We're not on AM activity, are we?
I hadn't heard if we are.
I don't know why we would be.
Oh, thank you, sweetheart.
Yeah.
And again, if you have a calculator at home or something, do bring it so I can get them inventoried.
I need to see God. I would never get tired of that short shorts.
So looking at part A, we would redo this and say that's log 13 over log 3. And we would put this in our calculator, and it would give us approximately 2.335. Here we would say log 10 over log 6. And again, that would be approximately, once we do our calculator, 1.285. And then in part C, we would say log 2, and then log 1/2, or log 0.5. I would rather just write log 0.5. And then that's going to give us -1. All right, so now we're graphing these, and one thing that we need to know whenever we're graphing, here's our equation that we given. And so with this, we have a vertical asymptote at 0. Our value is not defined here, so we need to keep that in mind. And then that's at x equals 0. And then we have our graph does something like this. And then we have, of course, here at 1, 0. And then we're going to have a point up here somewhere at b, 1. That's our base, 1. All right, so our characteristics, our domain is going to be from 0 to infinity. Our range is from -infinity to infinity. It is continuous, increasing on its domain. The symmetry is neither even nor odd. This is unbounded. Local extrema is none. This is not stopping for anything. Horizontal asymptote is none. Vertical asymptote is at x equals 0. And your end behavior, remember, we write that as a limit. So we're going to say the limit as x approaches infinity of our function. That one is infinity. However, our other side, our limit, x is going to approach 0 of f of x. And our function is approaching -infinity for that one. All right, so we're going to describe some transformations of this, and we're going to have our bases at 5. So it's going to be a little bit different here. I would start out with looking at this as log x over log 5. That way we can tell what's going on with it a little bit. Really, all of the graphs are going to basically look the same. Again, this is going to be another graph that looks something like this. So I wouldn't get too worried about it. Notice that you're going to have some kind of little shrink there going on, but nothing much. Now, our base here, 1/2, that does change a little bit. Again, you've got log x over log 0.5. And so that's going to swap things a bit. That's going to change it, and we're going to flip over. We're still got that 1, 0, but this is going to be flipped over a little bit. So that's going to be 1, 0. And that's really all we need to know for those. It's just noticing that fraction there does flip this over a bit. And then Here, we're still gonna be at that 1, 0 point for this one. They all look basically the same. All right, so for this one, we've got to draw a scatter plot. We've not done those, so we're going to omit this. We will do scatter plots, but it's going to be later on. So that'll be it for this part of our notes.